You want to watch a video?
No. We are videoing it, and there's a link on the Blackboard for YouTube, so that if you miss a class, you can catch it up, but also we have a couple of students who are on the sports admin room who are doing this class from distance. All right, I think we got to around here, right? Remember our triangle? We were discussing individual and environmental and task constraints. So as the teacher or the coach, that you want to be able to identify those and work out whether or not you can manipulate them to encourage the movement that emerges to be more like what you're looking for, right? Mechanically, effectively. Can I make it look more like what I want so the brain can learn the correct movement pattern, right? And it's important that we consider how the constraints interact with each other. If I change my footwear, but I don't change the surface, how does that impact the movement that I see? Or if the surface changes and I change my footwear, what am I going to see? Right? Things change. So it's quite a recent idea, this theory of constraints. 1986, we said this theory was published. So this whole idea of kind of considering the interaction of the three, this emerging movement, is relatively new when we're looking at the literature, right? But we can use it to help us explain how complex, right? Movement is complex. Changing movement is very complex. So the model just gives us a way of trying to explain, what am I seeing, why am I seeing it, how can I change it, right? It's not a right or a wrong. When we get into chapter 2, we're going to be looking at some other theories. A theory is just that. It's just a way of trying to explain something. So sometimes one theory does a better job in a particular context. Sometimes another theory helps you understand things a bit better. So you want to get as many of them as possible, as many perspectives, as many different ideas as you can, kind of build yourself a little tool belt so that when you're teaching and you come up against a problem, you've got lots of different ways of trying to tackle it. If the first one doesn't work, put it aside, try something different. Okay? Wow, wake up. Yeah. Okay, so now we're gonna watch a little bit. We're gonna watch a little clip here. Be thinking of our triangle. All right, what are you seeing when we watch this? And the one thing they didn't do on the new website was put the repeat little button on, so I have to keep clicking it. So, what individual constraints are you seeing when you look at this?
Just her size in general.
Her size in general, right? She's obviously quite young. If she's quite young, what does that mean when we think about experience or practice?
A lack of precision.
Right? A lack of precision. She may not have even ever attempted to kick a ball. You know, for all we know when we look at this might be her actual first attempt to kick a ball. We don't know, right? So, okay, what are the environmental constraints, do you think?
She's on the court, so she can wear tennis shoes.
Right, she's on a court. Do you think it would be easier or harder for her to try to kick this ball if she was on grass?
Maybe easier.
It might be easier because maybe, we don't know, but maybe she's a bit worried about slipping and falling over, right? What about task constraints? What are you seeing that would count as a task constraint?
Like the size of the ball.
The size of the ball. So how would you manipulate that? What might you do given what you're seeing?
The smaller ball.
Make it bigger or make it smaller? Yeah, it would be interesting to see which one made the best change, right? If I make it bigger, it makes it easier for her to kind of hone in on actually kicking the ball, not missing the ball. But at the same time, a smaller ball might be easier because she's not very strong yet. So you could play around with the ball and see which manipulation gave you a better version of kicking for this particular individual. Might not be the same for everybody. Is that? All right, out. Oh, where's the little, now we're going to get out of here. Here we go. Once you're in there, you can't get out of here. I can't, because I'm technologically defunct. All right, so there's a good activity on page 10 in your book there to help you think about that idea a little bit more, right? What kinds of constraints can you change to help someone produce a better movement pattern? So usually when we talk about motor development, we tend to discuss the average picture. What's typical? What do I expect to see on average with a particular individual given their constraints? All right. Sometimes an individual is going to be a little bit better than average. Occasionally, very rarely, they're going to be way better than average. And sometimes they're going to be a little bit delayed. They're going to be below average. And very rarely, they're going to be way below average. All right? So if you think about a normative curve, in a normative curve, a bell curve, what that tells us is that most people sit in the middle. Find a pen that works. Alright. So whatever kind of data you're looking at, really doesn't matter what you're looking at, whether it's academic or whether it's people in a shop or anything, we normally see a bell curve. So most data is going to sit around here, but you're going to get some data on either end of the bell, right? And that's what happens when we look at motor development and movement skills. Occasionally, though, we're interested in considering something that's atypical, that's not normal, right? So we might have a child with a very obvious physical disability, or we might have a child with a less obvious learning or cognitive disability that I can't see as soon as they walk into the classroom, for example. So I might have some differences in structural constraints or functional constraints that I need to take into account while I'm trying to help, right? Just because they have something different doesn't mean I shouldn't try to include them in the lesson and try to help them improve their motor skills, okay? So I have to make sure that I'm considering everything, because that person, when I consider the emerging movement that I'm going to get with the interaction, the movement's probably going to be quite unique. It's not going to be what I would typically expect to see, all right? So normally that means it's going to be delayed, so they're going to be behind where they should be. All right. Sometimes the difference in a constraint might mean they're never going to be at a normal or typical movement pattern. Sometimes it's that if I work with them enough, I can get them very close or even back to a normal typical pattern. Okay. So they may be delayed, they may look different. Can I help them be more like the average movement pattern? Because that's likely to be more effective for them if they want to try to use the skill to play. We don't want that adverb. Go away. Where's the little go away box? So this is in the Paralympic Games. So we've got people with all kinds of disabilities. So here we go. What does that mean? Okay. What am I going to see? What kind of movement am I going to see emerge given, in this case, the structural constraints that these individuals are confronted with? Right? So this is a backstroke race. This is very interesting, this chap. Look how they got around that. Here they go, same kind of start as a regular backstroke race.
So awkward on that.
It is, isn't it? It's cool, isn't it? Right? So does the movement pattern that emerges from this interaction look typical? Mostly no, right? It's not typical. Can it be effective? Clearly, yes. Would they win a backstroke race against a typical individual? Well, they would against me, right? But not against an Olympic swimmer, no. Right? But does that mean, I have to be able to adapt what I expect to see given the interaction of the constraints? It doesn't mean they can't do it. It means it's going to look different. And how do I help them be as effective as possible? Cool, huh? It's amazing. So, what changes then when we look at these? All right, here's the first one. Oh, what stage is this, guys? One. It's a very good picture of one, right? Look at that, absolutely hopeless. No use. Cute though. Very cute. But that throw is not going to be any good whatsoever. So we've got to do some serious work here to make that any use at all. Okay. So, now they gave him the same ball, right? but what else has changed? Right? Clearly he's grown, legs are longer, arms are longer. That plays a difference, as you'll see next week, with what you can do with the ball. Right? What about functional constraints? What's different here?
To move left.
Yeah, he does take a step, but that's not a functional constraint. What's the functional constraint? That's the stuff we can't see about the person, the stuff that's going on in their head.
Well, like you said earlier, I mean, you said boys typically are better with objects than girls would.
They are, because they have more experience. So experience, understanding a skill, is a functional constraint. Not only did he take a step, but he stepped in opposition. Right? So he's had quite a lot of practice, and he's got not necessarily cognizant understanding of the skill, but there's clear understanding by his brain that stepping in opposition is going to produce a more effective throw. Right? So lots of change between what we saw the little girl do. Wrong one. So we have a bit of a paradox. We have some contradiction when we look at development. And again, we're particularly interested in motor development, but it's the same kind of idea, whatever sort of development you're looking at, all right? When we look at people and we look at development, we find that because humans are all pretty similar, that there's some universality, okay? That means that if I'm a typically developing human, it doesn't really matter where I'm born on the planet, we expect the behavior to be somewhat predictable, all right? I'm going to stand up, I'm going to walk, I'm going to run. Typically. Not everybody does that, but that's typical. Right? So there's a universal, predictable pattern of locomotion for adult humans. Does that make sense? Right? However, within that universality, we have heaps and heaps and heaps of variability. Everybody does it different. Right? Not only do I do it on a different timeline, so on average, a human starts walking around 12 months of age. But the range of starting to walk is from about 8 or 9 months up to about 15, 16 months. So not everybody walks at 12 months. Okay? So the timeline can be different. The other thing that's very individual is the subtleties of the movement pattern. So if I filmed you all walking down the corridor or even more running, and we put that film up next to each other on the screen, you would see that although you're all running, you all look a little bit different when you run. Okay? So there are many different paths I can take to achieve the same outcome. No one does the same thing because none of you are the same. None of you are the same. You're all similar, but you're not the same. And when we look at biomechanics, it becomes really fascinating because you can even start to look at, well, where does the tendon insert on the bone? Doesn't matter if we're the same height and the same weight, the tendon may insert in a different point on the bone. And therefore, the movement pattern will be slightly different, right? If we had if we had the equipment to film something and look at it in that much detail, everybody does something different. Looks kind of vaguely the same. Right? Is that, okay? So nothing is ever the same. And actually, every time you do it, it isn't the same from the time you did it before. Right? There's always a little bit of variability in reproducing movement. So try to begin thinking outside of the box a little bit. All right? Don't always generalize about what you expect to see, because sometimes you might have to be a bit more flexible. So a little brief summary there. All right. Motor development as an area of study is looking at continual change, sequential change, age-related but not age-dependent change in movement, right? In motor behavior. Individual, environmental, and task constraints, so our constraints theory, our triangle model, underlie the change that we see. So it's the model is a very simple theory that can help me explain why something looks different at any one time. Don't worry too much about point 3. When you're going through chapter 1, you need to have a little bit of understanding about the difference between a longitudinal research design. So do I take a 3-year-old and watch that same 3-year-old until they're 23? Right? Or am I reading something where they took a group of 3-year-olds and they took a group of 13-year-olds and they compared the two groups? That would be a cross-sectional design. And you want to pay attention to that when you're reading, because that might influence the kinds of things they found and what they're able to talk to you about. Okay? All right. So, chapter 2. Okay. So let me turn the light on quick so you can see what you're doing. All right, I have 2 questions for you. Close your books. All right, 2 questions. First pre-chapter quiz. What we're going to do, you're going to write your answers down, and then we're going to swap papers. Someone else is going to grade and give you a number for that. And then Colton is going to collect them for me. So, first question. Chapter 2 gives us 3 main perspectives, approaches to studying motor learning and motor development. All right? Which one of the 3 does constraints theory sit under? Which one would be, okay, constraints theory goes with that approach to looking at motor development. Right, so I've got 3 perspectives. Which one does constraints theory agree with? Which one would it fit with if I was doing the jigsaw? So which perspective, which approach does our constraints theory, which is the thing we're going to concentrate the most on, fit with? And then your second question is, if I change the dimensions of the environment, or more likely a piece of equipment, an object, relative to the person's size. So if I'm teaching someone, I can't change the person's size at that time, but I can change the equipment that I give them, right? If I change the dimension of the equipment relative to the person's size, what's that process called? Right? There's a term, a name for that. So the first question, which of the three perspectives in chapter 2 does constraints theory fit with? And the second question, if I change the dimensions of the equipment relative to the size of the person I'm working with, what's that process called? What's the term for what I did? Any more time? Okay, put your name on your paper. Swap the paper over. So it doesn't matter whose paper you get or how many times it moves around, just want to make sure you don't have your piece of paper. Okay? Everybody got someone else's paper. Okay. So you're going to score them out of 2, right? So the three perspectives that this chapter looks at are maturational, information processing, and ecological. Constraints theory fits with ecological, fits with the ecological perspective. So today we're going to take a quick look at maturational, and possibly we'll get to information processing. But next week we'll look at ecological perspective and how constraints theory fits with that approach to looking at modes of development. Okay. So did they put ecological? If they did, give them a point. If they didn't, no point. Okay. Second question. If I change the dimension of the equipment relative to the person's size, relative to the size of the person I'm working with, what's that process called? All right? That's called body scaling. I scale the equipment to the size of the body of the person I'm working with. So if I make the racket smaller, that would be body scaling. If I'm working with a small person. So if they put body scaling, or let's see, what would be close? If they just put scaling, I would accept that. Okay, so if they put body scaling, give them a point. Give them a total out of 2, and Colton's going to collect those papers while we get going with chapter 2. Can you see when the light is off, Colton? Are you getting a good enough picture? Okay. glad to see you had lunches with you. Well done. You should eat that.
I just ate one. I got.
Munching is good. It's nearly lunchtime. I'm hungry already.
That one is.
Talking with your mouth full, not good. Not good modeling, probably. I'll hang on. The apple in my office. All right, so we're going to make a start on chapter 2. We should be finishing chapter 2 on Monday. So chapter 3 will start on Wednesday. Okay?
Right.
So, picture on the left is a 1-week-old baby, right? So this might be your baby, or this might be your sister or your brother's baby, or a friend's baby, right? You go to visit them, they're just out of the hospital, you go to say hello. And it's going to look something like that, kind of bleh. They yell, they wee, and they eat, and they sleep, and that's it, right? I don't have one of those, so I have pussycats, much simpler, right? So, 1 week old, very little going on here. Not only is there very little going on, but they're unable to move by choice. Right? They have no conscious, voluntary control over anything they're doing at 1 week old. So, do they move? Yes. But that movement is not voluntary. They're not in control of the movement that you see a 1 week old baby do. Okay? So, okay, you go home and you're in school, so maybe you can't get back to visit as often as you'd like. But you go back in about 9 months' time and this is what you see. And now, this child can sit up. Okay? It can reach out and grab something. It possibly has developed some form of self-locomotion. So it may be creeping on its hands and knees, or it may be sliding around on its butt, right? It's probably at 9 months either just about to or already started some form of making mum's life hell. Because she put it down and she walked away, and it used to still be there when she came back, but now it's gone. Okay? So at this point, life becomes a little tricky because they never stay where they're put in there. Okay? So in that 9 months, look at what has changed. Okay? That's amazing. Very few animals on this planet have that kind of development going on in 9 months. They're either born, most of them are born able to move in the first place because they want to get away from a predator. Okay? But they don't reach out for something a lot. You know, they're not cognizant, they're not looking around. A baby ape might be, but a baby bird's not a baby anymore by this point, it's already an adult. Right? So this is massive change in just 9 months, but it's not an adult yet. Can't stand up, can't walk. Give it another 9 months and you go back again. Now it's walking, it might just about be running, it's talking. So developmentally, things change a lot in the first year to 2 years. Okay. So, theories of motor development, I said earlier, theory is just a theory. Right? It's something, it's a tool that we use to try to help us understand what we're seeing. How did that happen? Right? What changed? What influenced the change? It could be. So the first perspective, maturational perspective, was dominant back in the early 1900s through to around 1960, so for quite a long time, okay? And the maturational perspective took the view, people who were studying movement or development at this point, and a lot of them were not, because motor development per se didn't really exist as a field of study. They might have been PE people, they might have been cognitive psychologists or developmental psychologists, right? So people who were looking at movement at this point in time believed that motor development was driven by maturation of systems in the body. So it was a nature-driven concept, right? It was all to do with your genetics, with heredity, and humans just did what they did, right? So there was just very minimal influence. They weren't interested in looking at what was going on in the environment at any one time. They didn't believe that that really played a big role. It might slow down motor development slightly, but they weren't looking at the fact that the environment could completely change the course of that movement, okay? And they were looking at very qualitative characteristics of motor development. What did it look like? What was the outcome? What was the product? Rather than the process. How did it change? Why did it change? Right? So it was invariable. Everybody was going to do the same thing. It was genetically determined. It was all to do with development of the nervous system and the maturation of the nervous system was the thing that triggered the appearance of the next skill that you saw, right? So children didn't walk because their central nervous system wasn't ready to turn those muscles on and make them walk, right? We don't really agree with that perspective anymore, right? The key though, because it was around for so long, the key point, the problem is that what occurred was that for many people who were looking at development, or for parents, or for PE teachers, it just became the belief, everybody just thought that fundamental motor skills, the things we've started looking at in lab, fundamental motor skills just automatically happen. I don't have to do anything. It's not necessary for me to teach anybody to run or to throw. As long as I give them a ball, they're going to throw. Right? So think about what we said when we were looking at our MSU chart. Does everybody throw well? Right? Now we know that's not true. I don't throw automatically. I get stage 1 if I give someone a ball. Right? And a lot of people get stuck at stage 3 if they don't have good modeling and good teaching. So we know now that that's not the case, but that idea is so pervasive out in society that even now you'll still get people who say, well, that's okay, I don't have to put them in PE, or I don't need to take little Abigail to gymnastics or to Little League. She's just going to learn how to throw a ball. It'll be fine. She'll run, right? When she's ready, she'll run. Okay? So we still hear things like that, even now, even though from a research perspective, we've known that's not true for quite a long time now. Okay? So that's problematical when you're a movement person, because it means people are less inclined to support what you do, because they're not entirely convinced that what you do is worthwhile. Part of the reason why we're losing PE. Why are we losing PE? PE is the most important lesson they do, in my view. Okay? So if we lose PE, the reason people argue to cut PE is, well, we don't need to teach them to move, they can just move on their own. So we can get rid of PE and we can use that time to teach them reading because they can't read on their own. It's not true, right? It's a fallacy, and it's causing a problem right now. You guys are going to come into hopefully the back end of it when you go out from school. It would be really nice if by the time you graduate, we're starting to see the end of this cancelling PE garbage, right? I'm not sure, hopefully. Okay. So, we don't need special training. We do know that mild deprivation, so if I have an individual who breaks their arm or breaks their leg at quite a young age, right? So let's say we have a 6 or 7 year old who breaks an arm or a leg, and they're in a cast. It's a complicated break. They're in a cast for 2 or 3 months, right? Is that going to stop them throwing well or running well? No, it won't take them very long to catch back up at all, given that. Severe deprivation, however, can impact motor development forever. So sometimes we hear horrendous stories where they found a child that was locked in a cupboard in the attic or something like that, right? Those children are unlikely to ever fully recover proper movement skills, proper speech skills, proper social skills, all kinds of things, right? Because the deprivation was so dramatic and long-lived that they never fully catch up. Okay? So, a break, getting sick and being in the hospital for a couple of months, you know, those kinds of things aren't going to knock an individual right off track. It'll just hold them back a little bit until they've had enough time to put in some practice and get back on track. So, maturation theory then, the nervous system is the most important system. Actually, even to the point where all the other systems are basically not significant. So the maturation of the skeletal system or the muscular system doesn't play any role in what we see movement-wise. Bizarre. How could the muscles not play a role in what we see movement-wise? Right? It's a bit of an odd now when we look back at it. It's like, that was a very strange perspective to take. But they did a lot of descriptive work. A lot of the information that we have now that we can use for stages initially came from the observations that they did back here. They just didn't approach that information in the same way. Okay. Then we get into the 60s and the early 70s. And when I was in school, this was the dominant perspective, information processing and all the theories that sit under that umbrella. Right? Information processing is a lot of fun, actually, as a perspective. It's really cool. And what happened was there was quite a strong change between believing that motor development, any kind of development when you look at young children, was driven by nature, to a belief that development was driven by nurture. So what I do with the child becomes very, very important in the outcomes and the behaviors that I see that child exhibit. Okay. Information processing in particular is looking at the human saying, okay, the brain is basically working like what we would now call a computer. Okay? I feed in some information, that information gets processed in the computer, and then it spews out some paper that says blah, 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 blah. Right? So in this model then, we have a passive human, and that human responds to things that are going on in the environment. Okay? So the input, the coding, the processing, the decision making, all those things become very, very important when we're looking at an information processing perspective. Okay? It was the first real attempt to look at the process of development versus just the product. What does it look like? Right? This was the first time people started saying, okay, well, I know what it looks like, but how did that happen? What the heck is going on inside that skull that came out the other end? Okay? So, in the maturational time frame, they spent a lot of time looking at infants and children. In the information processing perspective, the motor learning people started looking at young adults for a number of reasons. If you talk to some of them, part of it was, I don't like children, they're too difficult to work with, and it's way easier to work with adults. And part of it was the assumption that, you know, as an adult, everything else is finished growing, and so what I'm really looking at all the time is what is going on inside the head, right? Nothing else can be impacting that, because everything else is finished. So it made their life a little bit easier. So the motor learning people would look at adults, they'd come up with an idea, and then the PE people or the motor development people would take that idea and start comparing what they were seeing in the children to what the motor learning people had said was occurring with the adults. So it just started expanding a little bit. Right? So the brain is a complex computer, so the central nervous system is kind of a hardware, and my attention, my feelings, my mental processes, my reasoning about something that's happening, those are all the software type ideas. Right? So what we get then, can you see on the camera when I'm writing here? Mm-hmm. Okay. What we have, a very, very basic information processing model, looks like this. All right? Very basic. There are much more complicated models out there than this. Okay? So, box 1 is input. Right? I have to put in the information. When we're looking at movement, when we're looking at motor development, when we're looking at motor behavior, this box is going to be sensory stimuli of some form. Right? So the input into the computer is, what am I hearing, what am I seeing, what am I feeling? What's the sensory input? What's the information from the environment mostly? Right? Could be from an internal sensory organ, but generally outside. Right? What's the information from the environment that I'm sticking into the picture?
Touch, taste, smell.
All of that. Vision. Right? I'm watching the ball come towards me. Okay? Box 2 becomes, in the simple model, we just call it processing. Okay? But processing, this is highly complicated because part of processing is First off, this information comes down a sensory nerve and hits the brain. So, first thing that has to happen is the brain has to interpret what the information is. So, processing involves interpretation, right? Then having interpreted what it is, then I have to, then a really complicated bit comes. I've got to decide, well, what does that mean? What the heck am I going to do with it? Now I know what it is. What am I going to do with that? So the decision making goes in here, right? Very complicated. You're standing there going, well, how can it be complicated? Okay? But if I'm standing out on a field and there's a ball flying towards me, what are the decisions I've got to make? Okay, that's two. Do I move out of the way? What I do, move out of the way because I'm horrible at catching. Do I catch it? If I catch it, do I catch it with one hand or two hands? If I catch it with one hand, which hand do I catch it with? Right? Left. What if I'm not going to catch it? What if I'm going to kick it? Or head it? Or chest it? Or knee? Right? There's umpteen things you can do with a ball flying through the air. So, I might know it's a ball flying through the air. What am I going to do with it? Right? So the decision making, super complicated, fits in the processing. All right? I make the decision. I know what I want to do, but that's in there. And that isn't going to do it. These have to do it. So now I have to pick a particular motor program, and I've got to initiate the movement down to the muscles. Then we get to box 3, because at box 3 is the output. So if I'm looking at my computer, it would be the little data blurb that's coming out of the printer, right? In our model, my output is my observable movement. Right? So very simple model, but box 2 in particular is highly complicated. Okay? All right, so we'll pick up from there on